Hi everyone, Wednesday morning, welcome to your virtual maths lesson. As we always do, I don't need to explain really now. 4 questions plus the clock face on the screen. Give yourself 30 seconds, pause the video now. Question number 1, complete. 1/3 equals something 15ths. This is an equivalent fractions question. Remember, whatever I do to my numerator or my denominator, I do to the opposing one. So in this case, I've times my denominator by 5. So I do the same with my numerator to give me 5/15. Question 2, a division question, looking at using the bus stop method again that we looked at and practiced yesterday. The answer to this will be 142, hopefully. Question number 3, work out the area of the rectangle. We're looking at this question, area, not perimeter. We've looked at perimeter over the last couple of days. Remember, area is length times width. So I'm looking at timesing my two values together. 18 times 7, again, it might have been something you did using a formal method, should have given you the answer 126. I'm using millimeters as my unit of measure. And because I'm using area, I'm using my unit of measure squared. So it would be 126 millimeters squared. We're going to look at area and perimeter over the next couple of lessons. So if you're still a bit unsure with that, don't worry, we're going to come to it, as I say, over the next couple of lessons. Question 4, how many lines of symmetry does a rectangle have? It has 2 lines of symmetry. I use this rectangle here to show me I can use a horizontal line and I can draw on a horizontal line, going across, and a vertical line going up here to show that it's got 2 lines of symmetry. Time shown on the clock there, for those that can read it, is 17 minutes past 10. 17 minutes past 10. If you're a minute out because it was a bit blurry, don't worry. Okay, today's lesson, quite a short lesson today. I'm not going to talk too much about what we're going to be doing today. The what says there at the top, multiply decimals or any numbers really today by 10, 100 and 1000. This is a skill that we continually come back to because it's something that always crops up and it's always a challenging thing for us to get right. So I'm timesing by 10, 100 and 1000. Timesing means to move to the left. If I'm timesing my digits by 10, 100 and 1000, I'm going to be sliding my digits to the left. I'm making them bigger. If I'm timesing by 10, I'm moving one place. If I'm timesing by 100, I'm moving 2 places. And if I'm timesing by 1000, hopefully you've guessed it, we're moving 3 places. To help me remember those rules, okay, we use the number of zeros in the numbers to help us. So timesing by 10, I'm moving 1 place because it's got 1 0. Timesing by 100, moving 2 places because it's got 2 zeros. I'm timesing by 1000, I'm moving 3 zeros. Through 3 places because it's got 3 zeros. Now, this is really, really important. First of all, times by 10, 100 and 1000 should always be done, where possibly, done using mental maths. It's not something that requires you to write anything down, so no one should be using the formal methods for this. You might want to use a place value grid to help you slide the digits to the left if you're multiplying or to the right if you're dividing. You don't need to be using formal methods as such. Also, and a key learning point here for adults who may have learnt differently or learnt this differently, it's not just a matter of adding a 0 or adding 2 zeros or adding 3 zeros. We do not teach it like that anymore. In a moment, I'll show you an example as to why we don't do that and explain fully why we use the moving the digits method as opposed to putting the zeros on, which is how I learnt it, and it may be the case of how you learnt it also. But let's show you how we do it, and then we can explain the misconceptions that might come around by doing it a different way. So let's start with something as simple as 2.9 times 10. Now, excuse me if you find this okay, straightforward enough, and that's great if you do. Um, you won't need to be watching these lessons for too long. I'm not going to keep you anyway, because it is something we've covered already, so it's not something that should be taking too long to go over today. 2.9 times 10. Now, if I'm going to write that into my place value grid, which I'm going to do here, which you'll see a few of today on your worksheet, I write it in like so. Remember, my decimal point always comes into my ones column, my tenths column. It doesn't ever move. You always write your digits around it. We learned that from our decimals work a few lessons ago. From timesing it by 10, remember, we're looking at the number of zeros. Because I'm multiplying, I'm moving to the left. Because it's a 10, I'm moving each digit just one place. So if I do that, I'm moving the 2 one place, and I'm also moving the 9 one place. So I'm going to do that by moving them like so. 29.0 is my answer, or anything 0.0 is just whatever it is here. So in this case, 29 would be acceptable, or 29.0 would be acceptable. Now, I said a minute ago, maybe I'm talking more to the grown-ups here than I'm talking to the children, why we don't just ask the children to put a 0 in. Now, it's all well and good if I'm timesing a whole number by 10, 100, and 1,000. Yes, the rule does work. So if I was doing, for example, 3 times 10, it would be 30. If I was doing 15 times 10, it'd be 150, adding the 0. However, because higher up Key Stage 2, as we are now in Year 5, we look at multiplying decimals. This is where that method of just adding the 0 causes more confusion. If I was just to add a 0 here, that doesn't work, does it? It doesn't give the children the answer. The children do not get that conceptual understanding of the digits moving. So actually, by telling them to add a 0 for years, and I have been taught that way, I've also been taught a misconception, because adding the 0 isn't, it's just a quick fix rule for some examples. But for more complicated stuff, as I say now, 5 and 6 stuff for the children, it needs to be done where the digits are moving across. So we encourage the children, where possible, to either visualize this place value grid in their head or draw it out. Always draw it out. Guys, if you're unsure, draw the place value grid out. Today, you might want to draw yourself loads out and practice it in there and then check your answers using them. It's entirely up to you. Some of you might be a bit more fluid and a bit more confident, and if that is the case, you do not need to draw them out. It's not a necessity that you do draw them, it's just a method that you might use to help support you with your answers. Let's just get rid of these. Let's do 1 timesing by 100%. Let's do 1.34 times 100. Let's get rid of this here. Pull a place value grid in. This one's got thousands on it. It doesn't actually need 1,000 for this one, but some of them will do today. So 1.34. Again, just by adding my 2 zeros method wouldn't work here. That misconception I've just been talking about. Because I'm timesing it by 100, and it's got 2 zeros, and I'm multiplying, I'm going 2 places to the left. So my digits, oh, they're not all going to move. Let's do it together. I'm going to move 1 place, 2 places. So my answer would be 134. You could have put 0.0, as I've just said, or just kept the answer as 134. So times by 10, 1 place. Times by 100, 2 places. And we're talking about digits moving across the place value grid as opposed to putting the zeros in. Let's have one final example before I let you start. Let's have a go at 0.27 times 1,000. Add it into my place value grid. And then because I've got 1000. I'm moving 3 places to the left because I've got 3 zeros. So 1 place, 2 places, 3 places. Now the zeros disappeared off the end. It doesn't matter that it does that. Where I have a blank column, however, I do need to put the place value holder in. This is where I do need the 0. You only don't need to put the 0 is if you're at the decimal point, which we were for the previous 2 examples here. I did have a blank column though before the decimal point, so I need to put it in by filling it with the place value holder. 0.27 times 1000 is 270. So quite straightforward stuff, hopefully, for the vast majority of you who are confident with doing it. So today's focus is just multiplying, just moving to the left by 10, 100, and 1000. The worksheet, again, shouldn't take you too long to work through it. A lot of it's just practicing moving the digits to the left, as I've said, and as I practiced here. Some of it will be more tricky, not trickier stuff, but stuff that will just make you think a little bit harder. So, for example, something like, well, let's use this example here, written in a slightly different way. So it could be something like something times 1000 equals 270. Or it might be something, probably more something like 0.27. This is more what I'm looking for today, because that one I've just said there was actually more of a question you get tomorrow. 0.27 times something would give me 270. And in that sort of example, the children might need to, or you guys might need to, draw out the place value grid and actually move the digits across so you get from your starting number to your end number, and then however many places you've moved will tell you the number that you put into here. So that's it for me. Have a go. Let us know how you get on, and tomorrow we'll focus on dividing.